Good morning, sir.
Good morning. Let's wait for 2 more minutes in case anyone's joining. Then we'll see. How was your first lecture?
Good.
Our lecture is every time good for Anushka.
Our lecture is almost full. Why, sir?
Don't know, Anushka seems very happy in that lecture.
So let's start. Let me just present screen. Cool. Let's start. So last lecture, which was yesterday we started, yesterday we continued with, or we started with the ethos part of the chapter, which was nothing but the ethos process. Now, quickly revising ethos process from the start. What we understood in ethos processes or the objective of refresh. The objective of this entire concept of this entire chapter of ethos was basically where we understood Brownian motion. We also understood that Brownian motion do not have differentiable sample parts. Here we quantitatively saw as well that dBT follows normal distribution with parameter 0, dt. Hence, we quantitatively also saw that if I look at a very small time period of the Brownian motion, the characteristics of Brownian motion still exist, still persist. Hence, I needed a framework to differentiate or integrate Brownian motion, for which I have my ethos process. So we started with the revision of Brownian motion, wherein I have my standard Brownian motion. I accounted for my drift, diffusion, and non-zero starting point, came to general Brownian motion. In general Brownian motion, accounted for non-negativity and came to geometric Brownian motion. My standard Brownian motion is Bt following normal 0, t. General Brownian motion is xt following normal. I multiplied by sigma square, which is diffusion, added my drift, which is mu into t, and added my non-zero starting point, which is x0. After that, I know geometric Brownian motion is simply an exponential of general Brownian motion. Now, we revised martingales over here. We understood that ethos process gives you two rules or two frameworks. One is the differentiation rule, the other is the integration rule. The differentiation rule of ethos is called as ethos lemma. The integration rule of ethos is called as ethos integral. So the entire purpose, okay, let's do it later. Now, we then understood what an HDF as a stochastic differential equation is. It is simply nothing but when the change of one variable is expressed as a change and as is expressed as the change of another variable, that equation, that relationship is referred to as a stochastic differential equation. The example that we've done in Greek is, I know dCt is equal to delta into dHt plus gamma into dHt square by 2 plus rho into dr, vega into d sigma, so on and so forth. Here, what am I essentially doing? The change in option price is expressed as a change in the underlying asset price, change in the risk-free rate, change in the volatility. Thus, this is an example of a stochastic differential equation or an HDE format. We then just simply understood what integration is. How do I get integral f of x dx? And then we understood that the motive for our entire chapter is going to be two things. I may be given the process, I'll be asked to calculate the SD, or I need to get to the SD. which is xt to dxt. I know here I'll apply the differentiation rule or the lemma. We've seen single factor lemma already. The second part or the second objective is I may be given the HDE form, which is dxt. I'll be asked to come to the process form, which is xt. So here I'll have to integrate over here. So we saw over here Ito's integral in type 1, type 2 HDE. Starting with the first thing, HDE to process, which means I'll be given the dxt form. I'll be asked to calculate the process form. This may not be general Brownian motion. It can be any type of Brownian motion. I'll be given the HDE form of the Brownian motion. I'll be asked to calculate the integral form of the Brownian motion. Now, this can have three types of HDs. Type 1 HDE, I know any particular Brownian motion can be written as dxt is equal to mu dt plus sigma dbt. Now, type 1 HDE is where your mu and sigma, the drift and diffusion parameters, are constant values. That's type 1 HDE. Type 2 HDE is where drift and diffusion are equations of time, are dependent on time. That's type 2 HDE. Type 3 HDE on the other hand is nothing but where your drift and diffusion are a function of the process itself that you are simulating. It may have time, may not have time, but it is definitely going to have the process that you are simulating. These are the three types of HDE that we saw. We solved for the type 1 HDE, type 2 HDE. In type 1 HDE, I know my mu and sigma is going to be constant. So dxt is equal to mu dt plus sigma dbt. I need to get to the process. Hence, I need to integrate this. So integrating both sides from 0 to t. So I know, and I have nothing over here. Integral of 1 with dxt will be xt. In mu is constant, will come out. Integral of 1 with respect to dt is t. Sigma is constant, will come out. Integral of dbt or integral of 1 dbt is going to be bt. Substitute your limits, get the equation. This was type 1 HDE, relatively plain vanilla, relatively straightforward. Reason being that my mu and sigma are constant. They directly come out and I'm integrating with respect to whatever the HDE is. In type 2 HDE, my mu and sigma are functions of time. We took an example, let's say mu is t square plus 5, sigma is e raised to t. So I'm integrating both the sides or integrating my HDE both the sides from 0 to t. This is integral of 1 dxt, hence I can directly take this as xt. Now this is integral of t with respect to dt. So I know I can easily solve this using my traditional calculus. So I know t cube by 3 plus 5t. But over here, my integrals are on time. My limits are on time. My integration or the variable over here is time, but I'm integrating with respect to my standard Brownian motion. This is where the complexity, this is where all my rules of integration fails, that I have the time variable in terms of the integration, but I have to integrate it with respect to standard Brownian motion, which I know is not possible. Hence, that will stay as is. You will have the entire process form. Now, what you do is something called as Ito's isometry, which is simply nothing but from the equation you come to the distribution. So you start with dbt, follow in normal 0, dt, multiply et, so that will multiply square in the variance. Integral, so I integrate my mean, which is 0, so nothing will happen. Integrate my variance. Now limits are on time, variable is time, integrating with respect to time. I can easily solve this using my traditional calculus. I solve this integration. Whatever is added, I later add that to my entire mean. So this became your distribution form. This became your process form. This became your HDE form. This is where we complete HDE to process. Any questions till here? I'll then revise process first. Comfortable, everyone? All right. Now let's look at the process to HDE. Now, what is process to HDE? Process to HDE is basically I'll be given xt or I'll be given any particular Brownian motion. We saw we were given Vt, Gt, Lt in the last lecture, the sums that we did. They were a function of some particular type of Brownian motion. They'll give you in such a way some particular Brownian motion and they'll ask you to calculate the HDE form of that particular Brownian motion. For this, we derive the equation of single factor lemma. Now, what do I mean by single factor function, multi-factor function? All the questions, if you all see last lecture that we did A to E, all of them had only one variable, which was some particular type of Brownian motion. There was nothing else in terms of the inner equation. If I see the question, over here I have just xt, bt or bt. So irrespective of anything, the function or the Brownian motion or the process is just dependent on one particular Brownian motion. That is nothing but single factor function. Multi-factor function on the other hand will be, it depends on Brownian motion, but it also depends on time as a variable. So you'll, for example, have something like xt square plus t, xt square minus 2t. It depends on Brownian motion as well as it depends on time. That is nothing but what a multi-factor function is. I'll do it formally in the multi-factor lemma as well. But in the case of single factor function, I just have one particular Brownian motion. I start with my Taylor series. We understood in the Taylor series, under standard calculus, from the square term onwards, everything is zero. But under my stochastic calculus, my square term still remains significant. Everything from the cubic term goes towards zero. So I write my Taylor series, which is f of x plus h is equal to f of x plus h of dash x plus h square by 2 factorial f double dash x. I take my general Brownian motion as an example. So x will become my xt because that's what my process is. I add my small change dxt. So f of xt plus dxt is equal to f of xt plus the change is nothing but dxt and my derivative of the general Brownian motion. I substitute in my equation. I write dxt as mu dt plus sigma dbt because I know that is what the HDE form of general Brownian motion is. I solve for it. In the process, I understand two as the statements. One is dt into standard Brownian motion HDE is going to be 0 and standard Brownian motion square is nothing but dt. And dt tends towards 0, so dt square is going to be equal to 0. These are the three things that you will have to remember. Once you solve for your entire thing, you get what is called as your single factor lemma. Don't have to remember this equation. We'll do it today that this is already given in the table. We then solved a few questions wherein the only thing that you'll need to remember is your mu and sigma in the lemma are going to be the drift and diffusion of the inner Brownian motion. If it's SBM, it is always going to be 0 and 1. If it's something else, then they'll give you what is going to be the drift and diffusion. They'll give you in the format of this HDE. From here, I know that xt has the drift, mu t and diffusion sigma t. All right. Any doubts till here? Anyone? Comfortable? All right. Let's do now process to SDE, but for a multi time. All right. First, let's understand what a multi-factor functions. We've already looked at one of the multi-factor lemma, a multi-factor function. I'll take the example of the same thing. Let's take example of a call option. I know if you'll remember that table, factors affecting call option prices, we did positive, negative. If HT increases, what is the impact on price? If K increases, what is the impact on price? Can I say that factors that affect my option price is ST, K, sigma, R, time, and dividends? These were the 6 factors that even we drew or we plotted on the table. Now let's look at one by one. I know ST is very much a relevant factor for me. Now K, once I enter into the option, I know K is not going to change. There is no sensitivity, there is no variability of the option price to my strike price. Thus, this will be constant throughout my option period. Sigma, when we do Black-Scholes, we'll understand that the volatility parameter is assumed to be constant throughout the option period. That is what an assumption of the model is. So even this is going to be treated to be constant. Risk-free rate, you know that when we did Greeks, we said that in the shorter term periods, risk-free rate are not very susceptible to changes. They're relatively going to stay constant for like 1 month, 2 months because risk-free rate are generally government bond deals, which are not going to change for a short-term period. Thus, even this will stay constant. I know time is a very much dependent factor for me because time is going to change based on that my option price is going to change. For dividends, there is a separate model that we make for a dividend paying option. So this will also be in, but this particular model won't be considered, won't be incorporated. There's a separate model that gets built over there. I'll just try it over here. Separate model. Sigma is an assumption to be constant and rest young. This can I say what this result in is that the call option price is actually a function of HT and T. This is nothing but what a multi-factor function is. A multi-factor function is nothing but a function, a process which is dependent on 2 variables. Brownian motion as well as time as a variable. It can be any particular Brownian motion and time. With me? I want to just write the like a one-liner. Let me just roots and time of and time. Yeah, yeah. Cool. I want to copy this down.
So is it like the type 3 SD?
Somewhat like the type 3 HD. Like if you was to draw very crude parallels, it's like a type 3 HD. But like it's two separate concepts. Here the process is dependent on HT&T. There your drift and diffusion were dependent on process and time. Done? Okay. Cool. Now let's start the derivation for a multi-factor lemma. Now, in single factor lemma, we started with something called as the Taylor series. I know Taylor series was for a one-dimensional. So the Taylor series that we generally know is called as one-dimensional Taylor series, where the equation we know is f of x plus h is equal to f of x plus h f dash x plus h square by 2 factorial f double dash x, so on and so forth. Now, there I had only one variable, which was one particular type of Brownian motion, hence I could use one-dimensional Taylor series. But here, can I say I have two variables, Brownian motion as well as time? So here, if you need to derive your lemma, we need something called as two-dimensional Taylor series. This is given on page 3 of your table books. What two-dimensional Taylor series mean? F of x plus dx. You have one variable x, the change of x is called as dx. You have another variable y, because it's two-dimensional Taylor series, the change of y will be called as dy. So you have f of a function which has x and y, two variables. The change of x is called as dx, the change of y is called as dy. So f of x plus dx, comma y plus dy is equal to, if you see, I'll draw parallels with the one dimensional. First, I have f of x. So over here, I'll have f of x comma y. Then I have h f dash x. Here, I'll have dx into derivative of the function with respect to x. Plus, you take the other variable as well. Dy into derivative of the function with y. Alright. You had f of x. Here you have f of x comma y. Here you had hf dash x, but here I have two variables, so I'm taking both dx into d of f by dx plus dy into d of f plus d of f by dy plus h square by 2 factorial f double dash x. So here again it's h square, so I'll take both the variables, dx square by 2 second derivative of the function with respect to x plus dy square by 2 second derivative of the function with respect to y. There is one additional term over here, which is plus dx into dy, derivative of the function x comma y, partially with respect to x, partially with respect to y. This one term come out, so it's ideally like a plus b the whole square, a square plus b square plus 2ab. It's of those particular sorts. All right. This is what is called as your two-dimensional Taylor series. It's there in your
Two is
table.
there, no? Two.
Sorry.
That two.
No, that it's 1 by 2. There's 1 by 2 outside, so that 1 by 2 and 2 gets cancelled out.
Yeah.
Any doubts till here? Comfortable?
So I didn't understand the last one.
Last part. So if you see this equation, you have f of x comma y plus hf dash x with respect to x plus y f dash with respect to y plus you had x square by 2 factorial f of x, f double dash x. Over here, you have 1 by 2, but this becomes like a plus b the whole square because you have two variables now. So you have a square plus b square plus 2ab. When you open this bracket, it ideally becomes dx square by 2, derivative of the second derivative with respect to x, dy square by 2, second derivative with respect to y, plus it's like 2ab, but there's 2ab over here and there is 2 by division. So this becomes derivative of the function with respect to xy and dx into dy. This is what as is a Taylor series, two-dimensional Taylor series is. Like you have one-dimensional Taylor series, in the same way you have this as the two-dimensional Taylor series.
So, sir, like how the third term is derived at the two.
So it's ideally like when you go to your Taylor series, when you have your h square by 2 factorial f double dash x, here you take the entire square term of the second derivative with respect to x and with respect to y. You don't have the derivation. It's just that two-dimensional will be straightforward. Like from the table books, you can directly pick it up. It's that kind of thing.
So can you from that what is given in the tables, that formula, can you use that and draw a parallel with the final term?
Oh, the one that we've written. So if you
Yeah.
see for them, h and k are dx and dy. So they are writing f of x plus dx comma y plus dy is equal to f of x comma y plus dx into derivative of the function with respect to x plus dy into derivative of the function with respect to y plus h square or dx square by 2 second derivative with respect to x plus dy square by 2 second derivative with respect to y plus dx into dy second derivative of the function with respect to x and y. When they write f dash x with respect to x, it means it's like df by dx. When they write f dash x or rather f dash x comma y, f dash x comma y with respect to y, they are saying df by dy. When they say f double dash x comma y, xx, this means second derivative of the function with respect to x. So on and so forth. Understood?
So the last how is it df x comma y?
You are saying this.
Yes.
So you
Like,
differentiate the function first, assuming y is constant, take x to be the differentiation. Then you assume x to be constant, differentiate with respect to y. So it's a two-step differentiation. That you all won't have to solve this differentiation anytime, but that when we derive it, this entire term will go towards 0.
Provided
So
this
the-
order of this is valid, right? Dx,
Yeah.
dx dot dy or dy dot dx. It should be
Here
same.
it won't matter. Yeah. But
So
this will not come. You won't have to differentiate this. This is still the two-dimensional Taylor series. We haven't derived the lemma yet.
So like the double differentiation will be this one, like first x and then y.
First x and then first y. Yes. All right. Now let's apply our Taylor series, our lemma that we do. Can I say the first variable for me is xt? I'm taking a general Brownian motion plus the change in xt, comma. The second variable for me is time. So t plus dt. Let's apply this in our case. F of xt comma t plus differentiating or dxt into df by dxt plus dt into df by dt plus dxt square by 2 derivative of the function with respect to dxt plus dt square by 2 derivative of the function with respect to dt, and then the additional term which is dxt into dt into derivative of the function with respect to xt and t. Comfortable? The above one was a general two-dimensional Taylor series of the calculus framework. I applied that into my Brownian motion framework, wherein I know a multifactor function is general Brownian motion and time. With me? Now let's try to solve this. I shift this f of xt on the LHS. Can I say it will become d of f? I'll write f x comma y as f for now. Can I say this will become the SD of the function? I shift this on the LHS. So this will become the change in the function is equal to dxt. I know is what? Mu dt plus sigma dbt. I know that the equation of dxt is this into derivative of the function with respect to xt plus I can't solve dt. dt is ideally dt only plus dxt square will be mu dt plus sigma dbt the whole square by 2 second derivative of the function with respect to xt. Now, if dt tends towards 0, dt square is 0 that we've seen in that 3 condition. Hence, can I say this entire term will go to 0 plus the last term. I know dxt is mu dt plus sigma dbt into dt into df by dxt into dt. Let's solve this further. Therefore, df is equal to this. I can't solve. I mean, I don't know how to solve this, so I'll just open it up. Mu dt df by dxt plus sigma dbt df by dxt plus even the third term I don't know what to do, so I'll let it be as is. Now the fourth term, a plus b the whole square, it will open as a square plus 2ab plus b square. A square will be what? Mu square into dt square, which will be 0, plus 2ab. 2 into mu dt into sigma dbt. dt into dbt is 0. So even this 2ab term will go off. Plus b square is sigma square dbt square. I know dbt square is dt. Therefore, can I say this will become sigma square dt by 2 second derivative of the function with respect to xt square. Now, plus again over here, mu dt into dt is mu dt square, which is 0. Sigma dbt into dt, dbt into dt, I know is 0. Hence, can I say even this entire term will go off? Therefore, this will also become 0. Let me just write 2 zeros. Now, if I solve this, df, I'll take all dt terms together, all dbt terms together. So I have what? Mu df by dxt plus df by dt plus sigma square by 2 second derivative of the function with respect to xt square the whole dt plus sigma df by dxt into dbt. I've just taken all dt terms together, all dbt terms together because that is how my HDA looks like. This equation is called as multi-factor lemma. Now, if you go to your table books, let's draw parallels with the table books. Table book, let me just see where it is. Page
Need to check.
46.
So mu and A and mu are
Yeah,
interchangeable.
I'll explain. So now, if I'll go to page 46, they've given the lemma equation on page 46 of the table book. Let me just show you all what are the notations and everything that they are using. Yeah. So now this is what the snap from the table book is, page 46. They are saying dx is equal to a dt plus dzt. Therefore, can I say their a is actually mu, their b is actually sigma. What I had, dxt is equal to mu dt plus sigma dbt, and their standard Brownian motion is z. Now, if you see this equation, okay, this that's just saying dg, what we were calling f, they are calling g. So dg is equal to mu into df by dxt, a into dg by dx, plus df by dt, dg by dt, plus sigma square by 2, b square by 2, d square g by dx square, the whole into dt, plus sigma df by dxt, b dg by dxt, into standard Brownian motion dbt, here they have dz. So it's just that their a and b are mu and sigma, their standard Brownian motion is z, and their function is actually g. So you don't have to remember the equation at all. You can directly use it from the table book. Now, if you compare single factor lemma with multi-factor lemma, you all have single factor lemma with you? Copied? I think Anushka's closer. You all have single factor lemma with you all in your this. If you all see, the only difference between single factor and multi-factor is this term. Everything else is as is directly there in single factor lemma. The only term that is additional in multi-factor lemma is df by dt. And that had to be there because in multi-factor function I have time. In single factor function I don't have time. Therefore, this df by dt wouldn't have existed in my single factor lemma because I don't have time variable as the second variable. Even if you'll use multi-factor lemma for single factor function, this is going to be always 0. Because there is nothing time related, hence differentiating the function with respect to time is going to give you 0. So you all don't need to remember single factor lemma at all. You all can use multi-factor lemma. If there is nothing time related, you will get df by dt directly as 0. Understood? Alright, copy this down now. Let me know if you all have any question. Now we'll see how to apply multi-factor lemma.
Sir, so the question that I was asking before, so that in that we are differentiating two factors x and y. So that is the function like the df x comma y. I thought it is the like it is the final result after the differentiation. So that's
No,
why.
no, no. That was the two-dimensional Taylor series. Then we derived the lemma. So I don't have any partial differentiation, like two times differentiation over here. You
Okay.
will calculate df by dxt. You will calculate df by dt. You will second differentiate xt square. That is all that you need for this particular equation.
So the final equation we don't have to.
This,
Yeah, in the final.
in this, you don't have to differentiate once with xt, then the same equation with t. That's not there for us because that entire term became 0 because dt square was 0 and dt into dbt was 0. So that didn't exist for.
Okay.
So now, Anyone is copying this part? So that's that. Let me know Tom of Del Ramana. Perfect. Yeah, can you just check with Anushka once if she's joining? I think she's having network issues. Otherwise, we'll proceed. If she's going to join like in a minute, then I'll make the rest.
Yeah, I'll just ask. I'm not able to contact her. Like, she's
Cool.
having network problems.
Cool. Sure. Let's do two questions of how do I apply multi-factor lemma in terms of the processes. Let's take the first question. Let's say I have a process yt, which is xt square minus t, where xt is a standard Brownian motion. Calculate dy. So now I know yt is a function of two variables, xt, which is a Brownian motion, and time. Hence, I know it's a multi-factor function. So therefore, yt is equal to xt square minus t. Calculate dy. Remember, even here, mu and sigma are going to be the drift and diffusion of the inner Brownian motion, which in this case is a standard Brownian motion. Yeah, Anushka, you're left to copy ऊपर का. I think others are solving the question. तब तक you can just copy the lemma वाला piece. Yeah, Anushka, should I scroll up? Keep questioning. Done copying till here.
No, sir. I lost my connection, so I will try.
ठीक है, from the start कि इधर से बचा. Others are solving a question, so you can copy it at this तब तक. Hmm. It won't be dbt, it will be dxt only because the standard Brownian motion is xt. So it will stay dxt only.
What is the answer for that question, sir?
What did you get?
Yeah, that 2xt mu plus sigma squared minus 1 into dt, bracket dt.
Mu will be 0, sigma will be 1 because it's a
Huh?
function of standard Brownian motion.
What's
Mu
that?
will be 0, sigma will be 1 because it's a function of standard Brownian motion.
Yeah, correct. Yeah, mu is equal to 0, sigma squared is 0, 1. Na?
Sigma is 1. Yes.
Xt sigma dbt.
Done? This was fine. This is just from the table books, page 46. So that's fine. Now, the first question that we saw was that there's a process yt, which is xt square minus t, where xt is a standard Brownian motion. Now I know it's a multi-factor function because it's a function of Brownian motion, xt, and time. If they ask me to calculate the SDE form of this process, which is if they ask me to calculate dyt, I know I can apply my multi-factor lemma, which now I know mu will be 0 because it's a function of SBM. Mu of SBM is 0 into. Actually, let's first write everything that's given. So I know mu is 0. I know sigma is 1. What all do I need? Derivative of the function with respect to xt, derivative of the function with respect to t, and the double differentiation. Let's calculate all those separate. So dy by dxt, I know is 2xt. Second derivative of the function with respect to xt will be 2. And derivative of the function with respect to t, I know will be -1. These are all partial differentiation. So when you differentiate with respect to xt, t will be a constant. When you differentiate with t, xt will be a constant. So now when you apply dy t is equal to mu into df by dxt, I know 0 into 2xt plus df by dt, which is -1, plus sigma square by 2. I know sigma square is 1 square by 2 into double derivative. So which will become 2 the whole into dt plus sigma is 1. I know df by dxt is will be 2xt into, now remember standard Brownian motion is xt only over here. So I'll write this as dxt. Now, if I do this correctly, cancel -1 plus 1 will be 0. Is there anything? Yeah, this is correct. So now I know this is 0, -1. This 2 will get cancelled, plus 1 dt plus 2xt dxt. I know -1 plus 1 is 0. This entire term went off. Therefore, what do I get? 2xt dxt. Any doubts still here, anyone? Now, a very important thing. Can I say, I know the general type of Brownian motion is what? dy t is equal to mu dt plus sigma dvt or sigma dxt. If I don't have any dt term over here, can I say mu is actually 0 for this particular process? Again, I don't have any dt related term in this hd. If I don't have any dt related term, that means the drift is 0 over here. The mu parameter is 0. Therefore, can I say, since there is no dt term, mu, i.e. drift, is equal to 0. Now, is it ringing any bell? If drift is 0, can I say the process is a martingale? Why so? Martingale was what? Expectation of, I had S, I had T. Expectation of xt given Fs is equal to Xs. That means there is no increasing trend, no decreasing trend. It has to be a flat line, which means drift is ideally equal to 0. Can I say over here drift is actually equal to 0 because there is no dt related term over here? Therefore, yt is a martingale. When we did Brownian motion, remember I told you there is going to be one more approach to prove martingale. This is that approach to prove martingale. If you now compare, this is actually the question that we did even in Brownian motion. When we did martingales, we did this particular question and we proved this to be a martingale by splitting xt as xs plus xt minus xs. This is the other approach of proving it. And unless specifically asked to do it using Brownian motion,
Easy to solve.
Just a second. Unless specifically asked in the question to do it using Brownian motion, you will always follow this particular process, this particular approach. Reason being, you just need one equation over here, which is also given in the table book. You can easily differentiate the equation with respect to xt, with respect to t, double differentiate it, substitute everything over here. So it's just applying one particular equation. There, we had to split this in terms of xs, xt minus xs, segregate expectations, solve each of the expectation, which was a tedious process. Understood the second approach of solving martingales? Yeah, Tom.
Second approach is much easier. No?
Yeah.
That is why I asked you that some problem will be there, some formula will be there.
Yeah. Chalo. Copy this down. Whoever is done, try one more question. Question 2. Say yt is equal to e raised to lambda zt minus half lambda square into t. Zt is a SBM, lambda is a constant. Question is calculate T by T and check whether it's a martingale. Let me know if anyone gets the answer to the second one. Anyone? Question two?
Just the final line to write.
Sorry.
I'm just left with the last.
Take it done.
Lambda e to the power lambda zt minus half lambda square dzt.
Lambda e to the power
Lambda zt minus half lambda square t not dzt. Dzt.
perfect. Can I write this as lambda into yt into dzt? I know this entire thing is what? Yt. Thus, can I write this as lambda into yt into dzt? Now, there is no dt term even over here. Therefore, can I say this process is also martingale? This was the sum wherein we did that MGF of normal distribution or conversion to log normal distribution. Since more into power 5. Alright. Everyone take 2 more minutes. Solve. Let me know if you have any questions. You can do this from the starter, yeah. The writing yt instead of this entire thing. You can do it from the start where you're calculating dyt by dzt, dy by dt. Even there you'll have the same term. So you can write yt into whatever, yt into whatever. Just try dyt by dzt is equal to lambda into pi. P square yt by dzt square is lambda into other lambda square into y. And dyt by dt is equal to minus e raised to this, so e raised to this entire term. This becomes 0, so minus half lambda square. And your mu and sigma is going to be 0.
The last term would be minus half lambda square yt. Huh?
So take 2 more minutes, everyone. Let me know if you have any questions or not getting the answer. We'll then go to special cases.
Now I get so. We again put that YT factor. Sir, we have to put it on when we are differentiating or after differentiate or when we are putting in the formula.
You can ideally calculate all of these three first and then substitute in the equation. Will become easier.
Means I differentiate when we जैसे हम रेगुलर डिफरेंशिएट करते वैसे मैंने डिफरेंशिएट किया तो इट्स गिव्स द सम लॉन्गर वैल्यू बट एंड देन वी मिनिमाइज इट इन द lambda into yt.
Right. Yes. Done. I don't think the other two. Perfect. Let's go to now special cases. Now, these, as I said, when we did at the start of the chapter, we have two special cases in this particular chapter. They are called special cases for the reason that they are specific for they are there for specific underlying assets. We have two special cases that we'll see. The first special case is called as your share price process. The other special case is called as your IR process. So what these special cases are, in these special cases, we'll see what are the models, what are the Brownian motion, what does the SDE process and distribution form look like for the Brownian motion of the process that I'll use to predict share prices or equities, and what will be the case for interest rates. How will the process look like for predicting interest rates? Let's start with the first special case, which is share price process. Then we can take a break and then complete IR process.
After this, the chapter is over.
Yeah. And it solves sums. I think my lecture is on Wednesday or Thursday, one of the, I don't know what, I think Wednesday. I'll solve sums of ETOs that particular day, and then we'll start with Black-Scholes. Cool. Now, let's start with share price process. Again, revising, going back to our chart, I had standard Brownian motion, PT followed normal 0, t. The SDE form of PT, we now know follows 0, dt. I accounted or I solved for my dissimilarities. So in SBM, I solved for drift. I solved for diffusion. I solved for non-zero starting point. I arrive at my general Brownian motion. Now, for the purpose of this special case, we'll write the drift parameter of xt as eta. Because mu is getting used one more place further in the derivation. The drift parameter of general Brownian motion will be now called as eta. It's pronounced as eta. So I know xt will follow normal distribution. with parameter x0 plus eta t, comma, sigma square t. And dxt will ideally be equal to mu dt plus sigma dbt. These are my properties of general Brownian motion. And finally, I account for non-negativity. Arrive at my geometric Brownian motion, which is nothing but exponential of text. Okay. Can I say this st is ideally equal to e raised to x0 plus eta t plus sigma bt? I'm just substituting the equation of my general Brownian motion xt as x0 plus eta t plus sigma bt. Any doubts till here? Anyone? This we understood that when I had to predict share price, ideally it was the geometric Brownian motion, because I solved for all four dissimilarities, only then I ideally matched it with my Nifty share price or my Nifty movement. Thus, this is what your share price process is. We'll derive it based on this. So there are two parts to the derivation. The first part is where I'll use the equation of ST and derive the SDA form of ST. That's the first part. The second part is from the SDE, I'll derive the integral and distribution form of share price process. These are the two parts to the derivation. First, I know what the equation of ST is, what the equation of geometric Brownian motion is. I'll derive the SDE form based on that equation, and then from the SDE, I'll derive my integral or the process form and the distribution form. Comfortable till here? Let's do the first part. I know ST is equal to e raised to x0 plus eta t plus sigma bt. Can someone tell me whether it's a multi-factor function or a single factor function?
Single factor function.
0 is a constant. That's not a process. So forget about that. That's a constant value. So x0 is not a variable or a process function. Perfect. Because there's time and there's Brownian motion over here. If I want the HD, I know I have to go from process to HD. That means I need to use multi-factor lemma. For that, can I say I need to calculate dHT by dBT? I need to calculate d square HT by dBT square. And I need to calculate dHT by dt. I know ST is a function of standard Brownian motion. So mu will be equal to 0 and sigma will be equal to 1. First, let's calculate dHT by dBT. This will be as is into. I am differentiating with respect to bt. So this will become sigma. How did I do this? E raised to x will be e raised to x and then chain rule differentiation of the power. I'm differentiating with bt. So this is constant. Sigma will come out. Comfortable over here, or you all want me to write the step?
Comfortable, sir.
True. Now, second differentiating. Can I say in terms of double differentiation, this ST will still stay as ST and this will become sigma square. Okay. And dHT by dt will be ST into eta, because you'll get the coefficient of time over here, which is t. So ST into theta. Now let's apply the multi-factor lemma using multi.
Eta is a subscript or multiple factor. Eta into t.
Eta into t.
Eta into t.
Yes. So now using multi-factor lemma, can I say dHT is equal to? So, all right, let's write the multi-factor lemma first. Mu into dHT by dBT plus dHT by dt plus sigma, what is sigma square by 2 into d square HT by dBT square, the whole into dt plus sigma into dst by dbt into dbt. Fine with this? Let's substitute our values. I know mu is 0 plus dst by dt is eta into st plus sigma square by 2. I know the second derivative of this is st into sigma square. So I write this as correct st into sigma square. Sorry. I know sigma square over here is 1 square by 2 into d square st by dbt square is what? St into sigma square into dt plus what else? Sigma. Remember, this sigma is the general Brownian motion sigma. This sigma was the SBM sigma. That is why this I'm not writing it as 1. Plus, now I know this sigma is 1. dst by dbt is st into sigma into dbt. Now if I open this, can I say this will become eta plus sigma square by 2 st dt plus st sigma dbt. Now, can I say eta is a constant, sigma is a constant? Thus, can I write this as mu st dt plus sigma st dbt, where mu is equal to the drift of general Brownian motion plus the diffusion of general Brownian motion divided by 2. This is nothing but the SDE form of your share price process. Any doubts still here? Fine with me? All right. Now, let's do the second one and then I'll copy this together. The second objective was what? To get the integral and the distribution form. For this, I know I have to go from HD to Tom, can you mute yourself? Now, can I say I would now want to go from SD to process? That means I'll have to do Ito integral. In Ito integral, what I've seen, type 1 HD, type 2 HD, type 3 HD. Can someone tell me what type of HD is this?
Type
Type
3.
3.
Perfect, because drift as HD, diffusion as HD. So I don't know how to solve type 3 HD. Let's write at least the SD. dst is equal to mu st dt plus sigma st ddt. Now I don't know how to solve type 3 HD, but I know if somehow I can get this type 3 to either type 1 or 2, then I know how to solve it. I'm comfortable in terms of that solving. Let's try to do that. What is the factor that is giving me problems? ST? I'll remove ST from the RHS. So I write this as 1 by ST into DST is equal to mu dt plus sigma dbt. All right. LHS, looking at the LHS, is it ringing any bells? Any type of function?
There's a log DST.
Perfect. Perfect. It looks like 1 by
Differential of
1 by x dx, like your log. So you create another function. Let f, you can write f or whatever. Let f be equal to log of st. All right. I created a new function over here, log of st. Now what I'll try to do is I'll derive the SDE form of this particular function. All right. So df is equal to, all right, before that, everyone understood over here what I did? I created a new function f, which I'm saying will be log of st, because looking at this, I know that this type of SDE will be somewhere of the log of st. That is why I'm creating a new function log of st. What do I need? df by dst. What will be df by dst?
One by ST into log
1 upon
DST.
ST upon
DST.
I'm differentiating with respect to ht only, so there won't be any chain rule. df by dht square will be minus 1 upon.
Minus 1 upon st square.
Perfect. And df by dt will be what?
df upon- Zero.
Perfect. Because it's a single factor function, df by dt will not exist itself. Now, if I write the multi-factor lemma, df is equal to. Now, one more thing. What will be the value of mu? Anyone? Let's build up the thought procedure. The function, the inner Brownian motion is st. The hd form of st
Zero.
is what? Mu st dt plus sigma st dbt. Can I say the drift is mu st? Diffusion is sigma st. Therefore, can I say mu is actually equal to mu st? Sigma is actually equal to sigma st. With me till here? Now let's apply our lemma. Mu, which is mu st, into df by dst, which I know is 1 by st, plus df by dt, which is 0, plus sigma square, which is sigma st, the whole square, by 2, double derivative, which is minus 1 by st square, the whole into dt, plus sigma, which is sigma st, into df by dst, which is 1 by st, into standard Brownian motion, which is dbt. Now, if I solve this, st will get cancelled. This is the equation of d of ln st. st will get cancelled, mu plus st square will get cancelled. I have minus because there is minus 1 over here. So minus sigma square by 2 dt plus st will get cancelled, sigma dbt. Now, can I say this is type 1 HD? Because drift is constant, diffusion is constant. I know how to solve this. So what I'll do is integrating on both sides. What do I have? Integration of 0 to t, d ln st is equal to integration of 0 to t mu minus sigma square by 2 dt plus integration 0 to t sigma dbt. Now you just normally solve it. Can I say this will be ln st going from 0 to t? This mu minus sigma square by 2 will come out as constant. I'll have t going from 0 to t plus sigma will be constant. dt going from 0 to t. Can I say this is ln st minus ln s0 is equal to mu minus sigma square by 2t. The other term will be 0 plus sigma bt. B0 is 0. Starting point of standard Brownian motion is 0. Therefore, can I say ln st is ideally equal to ln s0 plus mu minus sigma square by 2t plus sigma bt. I want the process form of st, not ln st. I'll take exponential. What am I left with? ln s0 plus mu minus sigma square by 2t plus sigma bt. This is one of the equation. I can write this equation also as st is equal to s0 into exponential, because e raised to ln of x is x. So can I write this as mu minus sigma square by 2t plus sigma bt? The process form is what we derived. It can either be this equation or it can be the equation that I written it down. You can use any equation. So I derived the HD form, I derived the process form. Now the last thing, I need the distribution form. Distribution form is easy if I have the process form. Let's use this equation. BT. We always start with BT. So BT follows normal 0, t. I am multiplying sigma. Sigma BT will follow normal distribution 0 comma sigma square t. I'm adding this entire part in my mean. So can I say ln is 0 plus mu minus sigma square by 2t plus sigma pt will follow normal distribution with parameter ln as 0 plus mu minus sigma square by 2t comma sigma square t. Whatever I added towards the mean. Now, if this follows normal distribution, E of this will follow. Perfect. So therefore, can I say HT follows log normal distribution with parameter ln as 0 plus mu minus sigma square by 2t comma sigma square t. This is nothing but your distribution factor. Any doubts? Now, can you all go to the first chapter or second chapter, sorry, binomial model? In that we did something called a full normal model. If you all remember, wherein we derived the equation of u and d in terms of sigma. U is equal to e raised to sigma root dt. And I told you all that I'll derive this distribution later in the subject. This is that equation. We have used this equation in the full normal model, and here we've derived that equation. And this is the entire assumption for your Black-Scholes model. Black-Scholes assume that this distribution holds true. Understood? Perfect. Copy this down and then we'll take a break. While copying, if you all have any questions, let me know. The title is Share Price Process. Tom, you are on unmute. Everyone done? Should I scroll down?
Here we are assuming BT is the standard ground.
Yeah, because we started when we took the equation of general Brownian motion, I took BT only as the SB only. Understood?
break, no?
Sorry, no. People just copying this down. I think this is the last one. Let me know, guys, if you have any questions in the entire derivation. Purpose was we got the HDE form, we got the process form, we got the distribution form of the share price process. All right. Any questions with me? Ria, Tom, Abdul Rahman, Anushka, I can see on camera, so it's fine. All right. Let's take a break. 1 o'clock we'll join back. We just have one last special case, which is IR process. After that, we are done with the chapter. All right. So we'll end whatever time we completed. We'll end.
Derivations won't be asking, only problem solving will be asked. No?
No, derivations can also be asked. Cool. Let's join back at 1. All right. Let me know once you guys are back. Let me put the chat to- yeah, it's just- All right. Now, what do I do or what do I have in the IR process? Before getting to the IR process, let's understand something called as mean reversion. I don't think I've used this terminology here anytime. Now, what do I mean by mean reversion? So, practically, what happens, asset classes, specifically interest rates, what it exhibits is generally what happens is, let's say if I have 0 to 10 years, my interest rates are moving in this particular pattern, let's say. Practically, what we observe is interest rates exhibit something called as mean reversion property or mean reversion characteristic, which is basically there is a long-term mean reversion level. I've just drawn a dummy line. If I want, take the line over here. All right. Now, what the mean reversion level or mean reversion property means is, irrespective wherever the interest rate is, in the long term, they tend to converge towards a long-term mean reversion level. What do I mean by that? If the interest rates are up, they generally tend to come towards the mean reversion level. If they are down, they are generally pulled back up to the mean reversion level. In this way, I believe that whenever in the long term the interest rates are far from the mean reversion level, they'll tend to come back to the mean reversion level. Practically, interest rates exhibit property that over the long term, they generally tend to come to a mean reversion level. Obviously, this mean reversion level will change with respect to time. From the last 1 year may have a different mean reversion level than the last 10 years, than the last 5 years, the last 7 years, because the movement is different. But as a property, what mean reversion characteristic means is interest rates tend to come towards a constant level, a constant mean reversion level. If interest rates are below that level, they are pulled back to that level. If they are above that level, they are pushed back down to that particular level. Any doubts here? All right. So the property or the model that we use to generally model interest rates is called as Varsi-Chet model. That's the name of the model. Here the HD will be already given to you. You don't, in the previous one what we did, from the equation we derived the HD first. In this special case, you don't need to know how the HD is derived. The HD goes like dRT is equal to alpha into mu minus RT dt plus sigma dBT. Now, what do I mean? RT is nothing but my interest rate that I'm predicting. This is the SD form of that interest rate. Alpha is the coefficient of mean reversion. I'll write MR. Let me just define over here. Alpha is the coefficient of mean reversion. What this basically means is how fast is your mean reversion going to come at? For example, let's say if interest rates today, let me draw. Let's say this is the mean reversion level. Interest rates currently are over here. Now, alpha is going to control whether interest rates in the next 1 week will come over here or it's going to take the next 3 months to come over here. How fast is the interest rate going to come back to my mean reversion level is what alpha is going to control. The value of alpha is between 0 and 1. Alpha value closer to 1, that means faster will be the mean reversion. So in this example where I'm saying in the next 1 week it will come towards the mean reversion level, alpha will ideally be close to 1. If it takes 3 months, 4 months to come back to the mean reversion level, alpha is tending towards 0. Everyone understood what alpha controls intuitively? Mu is nothing but your mean reversion level. This level that we are talking about is ideally the value of mu. And now does it make sense? Mu minus RT is nothing but the distance from mean reversion. I'm multiplying that by alpha, which is ideally now your alpha controls the difference mu minus RT. Make sense? RT is nothing but your short rate. Sigma is nothing but the volatility of interest rates. That is normal. How volatile are my interest rates? HD, does it make logical sense now? You all need not know the derivation of this HD. This HD is what you'll have to remember. Yeah, go ahead.
Like, why are we subtracting RT?
So that ideally is the mean, but mu minus RT, can I say this will represent how far from my mean reversion level I am? If I am at the mean reversion level, this will be 0. If I'm above the mean reversion level, this is going to be negative because RT is higher than mu. If I'm below the mean reversion level, this is going to be positive. And as a magnitude, this is going to define how far I am. I'm multiplying this by alpha, which is ideally how speedily am I going to come back, or this is going to come towards zero. That is ideally how it logically represents.
So mu is the mean reversion.
Mu is the mean reversion level. RT is the short rate. Let me write it this
way. That means we are taking the difference between interest rate and mu.
Yeah.
We are taking the interest so that the balance will be left over, like.
Yes.
Some sort of a drift parameter we are deducting it.
Yeah. Understood, Ria? All right. Now, given that I know the HD, I just have to derive the process form and the distribution form. Now, let me write the equation again over here. DRT is equal to alpha into mu minus RT dt plus sigma dBT. Can I say I need to go from HD to process? Again, is it type 1, type 2 or type 3 HD?
Type 3.
Perfect, because in the drift I have my process itself, RT over here. Again, whatever is causing you the problem, remove it. So alpha U minus alpha mu dt minus alpha RT dt plus sigma dBT. The root cause of the issue was this alpha RT dt. I'll shift it on the RHS. So DRT plus alpha RT dt is equal to alpha into mu dt plus sigma dBT. Now, this you all may have to take from as a pinch of salt, considering as a derivation, you all may have to remember this step. But can I say this looks something like a UV rule? I have DRT over here and I have a RT over here, but it doesn't seem to be complete because I don't have anything over here to tell me that it's actually a UV rule. In such cases, whenever you have incomplete product rule, you multiply and divide by something whose differentiation and integration is the same. So at this step, you will ideally multiply and divide, or rather multiply, let's write, multiply by e raised to alpha t. Why alpha t? If you all need to remember, there is alpha over here, there is dt over here. RT I have over here. What is remaining? Alpha and t. So I'm multiplying by e raised to alpha t. Just as a way to remember. All right. Now let's multiply this e raised to alpha t drt plus e raised to alpha t alpha rt dt is equal to alpha into mu dt e raised to alpha t plus sigma e raised to alpha t dbt. Any doubts till here? Now, remember what I'm writing now is in brackets. It's a separate calculation that I'm doing, not in continuation to this. Can I say this now looks like a UV rule? Because I have e raised to alpha t RT. Let's figure out separately what kind of UV rule it is. So let's say I consider the equation d by dt e raised to alpha t RT. Because here I have dRT and here I have e raised to alpha t. So the UV rule would be something like e raised to alpha t RT. Let's solve this. U derivative of V plus V derivative of U. Derivative of U will be what? E raised to alpha t into alpha chain rule. With me? All right. Now if I write this as is, d by dt e raised to alpha t rt is equal to e raised to alpha t drt by dt. I'm just writing this alpha proper at the start. So alpha, or rather let's write this as e raised to alpha t alpha rt. Now can I say if I multiply throughout by dt, this will become what? T e raised to alpha t rt is equal to e raised to alpha t drt plus e raised to alpha t alpha rt dt. With me till here? Now if you compare, look at this equation and look at this equation. Are both of them the same? Thus, instead of this, can I write this? Now I continue my derivation. Instead of this LHS, I'm going to write this. So d e raised to alpha t rt is equal to alpha into mu dt e raised to alpha t plus sigma e raised to alpha t dbt. Everyone understood this step because I think this is the only step where students get confused. With me, comfortable? All right. Now, is it type 1 SD, type 2 SD, type 3 SD? Or rather, chalo, let's integrate directly because it's very confusing whether it's type 1, type 2, type 3. Let's integrate first directly. Integrating on both sides. Therefore, can I say integration 0 to t d e alpha t rt is equal to integration 0 to t alpha mu e raised to alpha t dt plus integration 0 to t sigma e raised to alpha t dbt. Comfortable till here? Now, can I say nothing over here? That means 1. Therefore, can I say this is actually equal to e raised to alpha t rt 0 to t is equal to alpha and mu are constant. E raised to alpha t will be e raised to alpha t by alpha 0 to t plus sigma is constant. This is like your type 2 HD. I'm integrating with respect, integrating t, but it's with respect to dbt. I know I cannot solve that, so I'll write that as this 0 to t e raised to alpha t dbt. Let's solve the other things. E raised to alpha t rt minus e raised to alpha 0 will be 0 minus r0. E raised to alpha into 0 is e raised to 0, which is 1. So I write that as this is equal to alpha, do I cancel it out directly? Because this alpha is as it is a constant. So this alpha and this alpha will get cancelled. What am I left with? Mu into e raised to alpha capital T minus 1 plus this I can't solve. So I'll write this as this. Now, can I write this as E? All right. Let's go step by. I'll write step up. R0, I'll shift it on the RHS because I need the equation of RT, not R0. So I shift R0 on the right hand side. Minus 1 plus sigma into 0 to t e raised to alpha t dbt. Now, what is extra? Alpha capital T over here. I'll shift that also on the LHS. So RT is equal to R0 e raised to minus alpha t plus mu into e raised to alpha t, e raised to minus alpha t will become 1 minus e raised to minus alpha t plus sigma into e raised to minus alpha. Here it's capital T, so I'm not putting it inside. I'll keep it outside only. E raised to alpha t dbt. Any doubts still here? This is nothing but the equation of your IR process. Let's see if I've derived it correctly. RT is equal to RT raised to 1. Yeah, perfect. Any doubts still here? Now I'm just left with the distribution form, which I know is easy. Let's start with DBT. What's the distribution of DBT? Normal.
Normal 0, dp.
Perfect. I'm multiplying e raised to alpha t. So e raised to alpha t dbt will follow normal distribution 0, e raised to 2 alpha t dt. I'm now integrating. So integration 0 to t e raised to alpha t dbt will follow normal distribution 0, integration 0 to t e raised to 2 alpha t dt. I know this I can solve easily. So I just solved that as well. So integration 0 to t e raised to alpha t dbt follows normal distribution 0, e raised to 2 alpha capital T minus 1 upon 2 alpha. Everyone understood this? All right. Now what I'm doing? I accounted for this entire part. I now have to account for this. I'm multiplying sigma into e raised to minus alpha t. So let's multiply sigma into e raised to minus alpha t. Integration 0 to t. You all are understanding this, right? Normal distribution 0, Can I say this will become sigma square e raised to minus 2 alpha capital T into e raised to 2 alpha capital T minus 1 upon 2 alpha. I am multiplying this, so I am multiplying the square inside over here. Now this I can solve. This e raised to minus 2 alpha T, I can actually shift it inside. In exam, if this question is asked, you all can directly do it. And no need to show it in a granular step. Right now, I'm showing granular steps for you all to understand. Can I write this as sigma square 1 minus e raised to minus 2 alpha capital T upon 2 alpha? Everything related to multiplication is done. I'm adding this entire thing. Whatever I add gets added to the mean. So can I say RT follows normal distribution. R0 into e raised to minus alpha T plus mu into 1 minus e raised to minus alpha t, sigma square into 1 minus e raised to minus 2 alpha t by 2 alpha. This is nothing but your distribution.
Is it available in the book?
Sorry?
It is not available in the book, I think.
No, this one is not available in the book. Any doubts still here? One more thing remembered, this derivation, entire derivation we did for the Vasicek model, which is this particular equation. There is one more IR process called as OU process. The full form of OU is Ornstein Uhlenbeck. Uhlenbeck. A guy's name, obviously. So even this is an IR process. Entire derivation, everything remains exactly the same. There, mu is equal to 0. That's the only difference. Your SD therefore actually becomes dRT is equal to minus alpha RT dt plus sigma dBT. He assumes that the long-term mean of interest rates is 0. That is what his assumption is of a model. Thus, your entire derivation that you are doing will remain exactly the same. This mu term will become 0. That's the only thing that will change. All right. Fair enough.
It is a particular UR process, is a particular case of HR, no? That,
Yes.
That
Yes.
Basic process.
Copy this down. Let me know if you all have any questions. We are done with the chapter. Next lecture we'll solve questions.
So there are 4 models are there: Holy, Whole White, Basic, and
Sir,
Cough, Ingress, Rose.
That will do next lecture when we do.
Yeah, only Basic we have studied, I think. And UR is not given here.
That's not there. Yeah, understood.
sir, in this OU process, if U is equal to 0, then why that all parameter can't become 0?
Why?
Why that all parameter means minus alpha RT dt. It should, why
The
it can't?
drift is not equal to 0. The long-term mean reversion level is 0. All right, only this parameter is 0. In this case, the drift is what? Alpha into mu minus RT. That is the drift. I'm not saying the drift is 0. This mean reversion level is 0. Understood? Good question. So now I think now it's a good position to ask, how do you like FE?
Derivation is okay, sir. Better than the other one, no? That the options one law and all. But these things are derivation. If you like derivations, it is okay.
Yeah, it's like notations.
Derivations is okay. It's not like options. Options and all. No, it takes problems. It comes. It is very complicated. Sometimes
Next chapter is not entirely options only. Next
options
chapter
and
is
features. Sometimes problems become complicated, but it takes time also. But here, this is at least derivation. No, we can people who likes derivations. It is okay. For me, this I am very comfortable.
fair.
Only thing is that the problems comes. We have to practice a lot.
Different form, yeah. Wednesday we'll practice sums of this chapter only. I don't want to start Black-Scholes directly. We'll solve this chapter ka questions, then we'll start. Black-Scholes is the last significant chapter that you'll have. After that, the last two chapters are like relatively shorter. As I said, 1-2 lecture chapters there.
अच्छा है सर, इतना बुरा नहीं है, इतना सोचो.
FE लोगों को बहुत difficult लगता है, but if you understand and sit like Brownian motion से Black-Scholes तक completely, then I don't think there'll be a problem from an understanding point of view. Because people miss the link if they don't sit for Brownian Etos, you all are not going to understand anything. Like here, if no one has sat for Brownian, they wouldn't know what is drift, they wouldn't know what is diffusion. So udhar logo ka link.
All are linked together. At least one class goes, gone. Everything is gone.
Yeah, it's gone. That's why I think the last chapter, Black-Scholes, after that, the condition that I had put that please attend lectures, that gets over because the last two chapters are independent. And once you understand it conceptually, then you know the entire time that you need to put is for practice only. I'm considering like next week, I think I have Saturday, Sunday, 1 weekday, and I may have one more weekday. So if that is the pattern, I may complete Black-Scholes and by Feb end only.
Problem with that MCQ question is a problem because it takes someone the script at least 2 hours. This MCQ only 1 hour now with 30, 11, 15 questions. So one mistakes cost a lot.
That is the time management you need to have in FE. Time management, I think no one can know best than Ria.
Some mistakes we commit now, then it is a problem.
Yeah.
At least 2 hour, 3 hour problem, so we can derive it and also.
Well,
I don't know, sir. Maybe I made mistakes in the book.
you scored good now in F1, at least overall. Let's see, FE or papers will also come. I mean, the external papers for the books.
We'll try to score good here as well.
Yeah, I mean, this semester, so I generally suggest students, except CP1, for all the other 6 papers, at least get CM2, CS2 exemptions. Because those 2 papers are difficult to clear separately outside. So CM2, CS2, at least get it exempted from your, because it's still in a structured way and everything. So this semester you all will come to know about CM2 because 80% is covered in this semester. So PTSA and this. How is PTSA going?
It's okay. Only thing is that downside, this is okay. It's and upsides.
So, like, what have you written in the right side? Mu is equals to 0. Acha, that is for the OU process.
Yeah, this part, so this you can ignore. This you can ignore. So ideally, we've done two derivations in this. One, we've done the derivation for Vasicek, the other derivation is for OU. So they can ask you as IR process, they can even ask you OU process. OU process is no different than Vasicek. It's just that the mean reversion level is 0. You will do entirely the same concept. Everything will remain the same, but with mu is equal to 0. That's the only thing that I.
It's negative, no? Negative drift and all.
Lecture today. Plan also the group. बताने वाला था आपको. This lecture is on Wednesday.
Individually, the subject would be fine, but comparatively with other subjects, the different notations, so that may be a problem.
And this FE, right? Because everything is new notation, Brownian motion, Eater's process is learned for the first time. Everything with new notation. That's where students find it thoda difficult. That's why this subject I generally instruct the admin to keep the lectures or like before towards the start of the semester and get it off, because towards the end I cannot rush this subject. Like this like FM was still like annuity, the same concept were being carried forward, so that I could still rush because entirely numbers. But this subject cannot be rushed towards the end. So that's why I keep I if you see the order as well, I'm not taking it in the order of the syllabus objective. I've changed the order to cover all the significant chapters at the start, so that even if towards the end we don't get much time, the shorter chapters get done. Syllabus object also.
So why did we multiply by E?
Because I wanted to get rid of this alpha RT. This was type 3 SD. I wanted to convert it to type 1, type 2 SD, and the RHS now looks like a type 1 SD. Or rather, it's not looking like a type 3 SD. So I need to figure out what I can bring on the LHS in order to get this type of SD. And on the LHS, I know it looked like an incomplete UV root. So I multiplied by e raised to alpha. want to write this as 1 slash 2. This is, I believe, right? 1.
So basically, what we did is we had the SDE and
Yeah,
we got into the process.
process. Yes.
For simplification, we multiplied e raised to alpha
Yeah,
t.
because that SDA was a type 3 SD. I
Mm.
can't solve type 3 SD directly. So I figured out a way to get the type 3 SD to a type 2 SD. And then I'm solved.
And lastly, we did the integration.
And we did the integral. And from the integral process, we just derive the distribution. If I just between today, I think my next lecture will be on Wednesday only. So between today till Tuesday, just go through the entire chapter, both Brownian and Ito's process. We'll, if you all have any questions, we'll solve that and then we'll solve this. So, Avani absent, Hansraj absent, Rasitej absent, Ashok absent, Kaustubh was not there. He was just for 5 minutes. Martin absent, Riya present, Anushka present, Abdul Rahman Al Mark present. He was there for most of the lecture. Tom present. RT is interested, yes. That's the short rate. What do I mean by short rate? At this second, what is the interest rate? That is what RT is. Riya, Anushka, Abdul Rahman, Tom. So if I have to predict, let's say USD interest rates, I'll take a starting point for USD interest rate. I'll estimate the coefficient of mean reversion for USD interest rate, take the long-term mean reversion level, fit everything over here, and then predict my RT. Long mean reversion, long-term mean reversion. So ideally, I say that over the long term, it will converge at this particular level. That is what your mu is, nothing. That is what your mu is. Because in a short term, there will be a lot of fluctuation. It may not revert to the mean reversion level, but in the long term, it will revert to the mean reversion level. Let me see if I can show you all.
Sir, can you scroll
Now,
down?
We will be finishing now, sir, or we will be closing it now.
sorry.
We are closing it now. We are closing.
Sorry.
Now. We are.
Yeah, we'll end for the day. If you are done copying, you can leave. I've taken the attendance.
Sir, like what is after this?
What is?
After this bit, after this.
Done. This is the last.
Sir, like can you repeat the graph of mean reversion once?
No, that I was finding, but I didn't get it. It's not publicly available. I was showing that if interest rate move, ideally there's a long-term mean reversion level. Let me show this one if you want. For example, if you see this graph, if you see this graph, over the long term, it is moving around 5.3 only. It went up, came back towards 5.3, and then it's ideally 5.3 is nothing but this level. If you see, your interest rates is tending towards zero. It went up, coming down, went up, pushed back down, went down, pushed back up. Similarly, went up, pushed back down, and now it's again coming up over here. So this is nothing but an example of mean reversion. But if I would have seen only this much of the history, I would have taken the mean reversion level to be this. But I know now it's diverting from the mean reversion level. So ideally, I wouldn't have taken this. And I know this is happening over the long term only. That is what mean reversion property means. And practically for interest rates over a very long duration, you will see this property to hold true. Just minimize this and keep it for all. Plus with now it will go to this 5. Done?
Also, can you show the OU process?
Oh, you process now. It's exactly, or the entire derivation is the same, only just mu will be equal to 0.
So we have to मतलब हमें अपने तरफ से करना पड़ेगा म्यू 0 लेके ये सॉल्यूशन
हाँ मतलब if you want तो कर सकते हो, वरना you know same ही होने वाला है. If the final answer will also be the same, just this mu term will be equal to 0. So this term won't be there in your answer. That will be the only difference.
Sir, I have doubt in that 9 variation is that कि वो जो 9 variation है उसमें बायर और सेलर का पर्सपेक्टिव है क्या दोनों का दोनों की तरफ से या ओनली वन
From the buyer.
ओनली ऑन द बायर पॉइंट ऑफ व्यू 9 वेरिएशंस उसका उसमें सेलर का कोई ये नहीं है.
Whatever forward pricing आए तो वही वेरिएशन में से कुछ तो करना है. डिपेंडिंग सिंगल इनकम है, सिंगल कॉस्ट है, कंटिन्यूस इनकम है, कंटिन्यूस कॉस्ट है, क्या है.
सो हम जब वो 9 वेरिएशन करते हैं तो जो इक्वल टू के दोनों साइड्स होते तो उसमें हमें जब में हम स्टडी कर रहे थे तो वी थॉट लाइक दैट कि एक साइड जो है बायर की तरफ से और दूसरा साइड सेलर की तरफ से, ऐसा कुछ नहीं है ना?
नहीं,
ओनली बायर्स कॉल मीन्स कि
फ्रॉम द लॉन्ग टर्म।
हाँ, सो टुडे आई एम,
और ये क्या
मुझे
होगा?
कि आज मुझे सॉरी टुडे मुझे फॉरवर्ड का कॉन्ट्रैक्ट बाय करना है, तो मैं उसका फ्यूचर प्राइस निकाल रही हूँ।
एग्जैक्ट,
हाँ,
एग्जैक्ट।
ओके।
Yeah.
Can you go to the step equation one? And this is derivation. The two equations we used now before, number 1 and 2. Yes. So yeah, after this purple part, usme like why are we taking these two terms like differentiating
This term?
e to the power alpha t and rt? We are differentiating. No, we are not.
So this I'm doing a separate thing, that this looks like a UV rule of e raised to alpha t RT only. So I'm seeing that whether it's actually the UV rule of e raised to alpha t RT. So when I do this, I realize, oh yeah, that's actually the UV rule of e raised to alpha t RT. Hence, instead of this entire thing, I now write this part.
So we are UV rule of differentiation.
UV rule and differentiations.
Okay.
Done? Copying? Alright. If you all have any doubts, you all can ask. If you all are done, I've taken the attendance, or you all can leave and enjoy the rest of your Sunday. Switch off the recording.